For Freshman Engineering Design Day, our group did 3D printing.
Compared to other technologies, 3D printing is pretty new. A basic 3D printer is comprised of three parts: a Cartesian robot, the thermoplastic extruder, and the print bed. The Cartesian robot uses precise linear motion to move in the X, Y, and Z directions. Utilizing small stepper motors, the robots can move distances as small as a fraction of a millimeter. When this is accompanied by the thermoplastic extruder, the robot can begin printing. The extruder, similar to a hot glue gun, will emit a hot thermoplastic. The thermoplastic has special properties that will allow it to soften to a semi-liquid state when heated, and will harden soon after it is emitted. This thermoplastic base will be printed on the print bed. The print bed is the surface at the bottom of the printer that houses the 3D prints and is both warp resistant and crack resistant. As one might expect, the use of a 3D printer comes with the risks of malfunctions. A team of students at NCSU set out to fix a problem of warped designs caused by low-quality printers. Because the problem came from inconsistent heating throughout the printer, the team came together to produce an enclosement for the printer that would keep it at 70 degrees Celsius.
The present uses of 3D printing include the printing of organs, tissues, and prosthetics. 3D printing is also used to prototype in the automotive industry. The industry also uses 3D printing to fabricate lightweight components to increase gas mileage. Even NASA sent a 3D printer to the International Space Station so that they can fabricate parts and tools in space. In the future, it is expected that personal 3D printing will expand to a majority of households. Also, as time goes by, new methods are expected to be developed to improve the overall printing process.
For our assignment, we needed to create a product that one would want to use on vacation. The product needs to have two different functions. It also needs to be made using at least 75% of 3D printed material. Our product is designed to be used at the beach. We wanted it to be a simple amplifier that does not require batteries. That way, the user doesn't have to worry about forgetting them. It was also important to us that the amplifier stays off the ground. We know users do not want to get their belongings sandy, so our product hangs off the ground by hanging on a beach umbrella. When you're done listening to music and ready to go in the ocean, the product doubles as a storage container. You can leave smaller precious belongings, like keys, your wallet, and phone, in the container. The container is water resistant and sure to keep your things sand-free. It closes with a removable lid.
For our designs, we use Google SketchUp. In retrospect, we should have used something like Tinkercad, as the problems we faced with SketchUp was that it didn't have a way to natively export an STL. We had to use third-party programs to produce the appropriate files. This slowed down our design process considerably. Our first design relied on a clamp design where the device would utilize a fishhook screw to tighten around the pole of an umbrella to secure itself. It featured hooks to hang stuff like towels off of it. However, we eventually changed our design before our first print when we realized that the plastic used to print is too brittle and not malleable enough. This design would not have printed well anyways due to the irregular and unstable shape of the model. For our second design, we decided to use carabiners to hang the device off the top ribbing of the umbrella. The bottom portion of our design printed fine, but the cone section failed to print and collapsed due to lack of structural supports. In this design, we switched out the hooks for a small well that would hold items like keys and small pocket items. We tried to print this a second time, but was stopped when we realized that with added structural supports, the device was too large to print. This is our final design. We printed it in 4 separate pieces: the speaker, the hanging bar, and the lid, which printed in 2 pieces. We decided to combine the speaker function and the storage function into one cylinder to reduce plastic use and improve its ergonomics. The lid provided a water-resistant seal protecting the contents inside. Some problems we had with this final design was that the measurements were slightly off and we had to sand edges of the lid for it to fit over our speaker. One thing we could have changed was our choice of carabiners. 2 S-shaped carabiners that are also larger in size would have improved ease of use when attaching and detaching the device from the umbrella.
At Freshman Engineering Design Day, the pack and howl did not have any malfunctions. It worked well and produced the desired effect. Our group, PawPrint, ended up placing 11 out of 18 teams in the 3D printing section. While it may not be in the top 3, improvements to our design may have enhanced the judges' ratings. First, the carabiners were finicky and could be replaced by a better, more simple fastening mechanism that would be able to hang from a variety of umbrellas. Second, the container, while watertight, could have benefited from a design that would make it easier to open and close.
After completing our project, we have some advice for future engineering students with FEDD. Be sure to start work on your project early. This is especially important for the 3D printing project. 3D printing takes a significant amount of time, and your initial designs may fail. It is important to account for this when making your timeline. Speaking of which, it is essential to create a plan with your group and stay with it. It is easy to fall behind if you don't have a set timeline. Lastly, communication among group members is absolutely necessary to ensure a successful project. I recommend starting a group chat on GroupMe and getting each other's emails as soon as you are assigned your group.